All right, lesson number 6, we're talking about Cpctc. What in the world is that? Your learning target is I can use Cpctc to prove parts of triangles are congruent. All right, let's go. So the first thing we need to explain is what in the world is Cpctc? And I know I'm going to run out of room here, but what Cpctc stands for is that corresponding parts, I'm going to write it kind of small because we're going to have a lot here. So corresponding parts of congruent triangles are congruent. Okay? Cpctc. Oh, that's crazy. They're smart. So corresponding parts of congruent triangles are congruent and is used to justify two triangles are congruent in a proof. All right. So essentially what we're doing here is if we know that two triangles are congruent, then we know the corresponding parts of two triangles are congruent. Doesn't really, there's not a whole lot different, but we use Cpctc in proving triangles, proving certain things about triangles. Okay, let's do some examples. All right, example 1 shows how Cpctc really works right at the get-go here. It says that A and B are the endpoints of a bridge going over a river, and we want to know what is the length of the bridge. All right, if we look at this here, we can see that we have corresponding parts, corresponding sides on both of those, and these are vertical angles, which means that these two angles have to be congruent. And so because of that, we know that these two triangles formed here are congruent based on SAS. Remember, side angle side congruency. We've got a side angle side is corresponding and congruent to a side angle side. Okay, and if that's true, if those two triangles are congruent, then the length of this bridge will be the same distance as its corresponding part on this triangle, which is 18 miles an hour, or 18 miles as their distance, right? So we've got what is the length of the bridge? 18 miles. Okay, and we know that's true based on Cpctc. We proved first based on SAS that the triangles were congruent, and because of that, this corresponding part to here is going to be the same, so it's 18 miles. That's all that Cpctc really does. Example 2. All right, example 2 says, given that YW bisects XZ and that XY is congruent to YZ, we need to prove that this angle XYW is congruent to ZYW. And so let's first start off like we do any proof. Start off with the first thing that's given. And the first thing that's given is that YW bisects XZ. Okay? And the reason again that we know that is given information. That's all given information. Okay? Now, based on that, if YW bisects XZ, that means that XW has to be congruent to ZW, only based on that's what a bisecting line does, right? So the second statement we can put here is that XW, line XW, is congruent to ZW, and that's because that's the definition of bisector, or bisecting line. That's what a bisecting line does. It cuts things in half, okay? All right, so we now know that we've got XW, and that is congruent to ZW. Let's go ahead and go to our third thing, or our second thing that's given. We know that XY is congruent to YZ. Okay, again, that's given information. So we can make those markings on here, and we can see now. There's one last thing that we need to identify, either an angle or a side, to prove that the triangles are congruent. Okay, and so we can say that YW, this line YW, is congruent to YW, and the reason for that, it's the same line, or remember that's also called the reflex property of congruency. Okay, so finally this third line, the one in the middle here, is the same. So we know these two triangles are congruent, and we can write that as this next statement is that triangle XYW is congruent to triangle ZYW based on SSS, right? Okay, but remember, that's not what we're trying to prove. We're not trying to prove that the two triangles are congruent. We're trying to prove that XYW, that angle right here, is congruent to ZYW. But because we've proved that the two triangles are congruent, we can say then that angle XYW is congruent to angle ZYW based on the corresponding parts of congruent triangles are congruent. Cpctc. If all of these, if we found that these triangles are congruent, then all of the corresponding parts will also be congruent. That means every single one of these angles have to be congruent as well. All right, let's do the last example. All right, example 3 says the given that D is -5, -5, E, -3, -1, F, -2, -3, G, -2, 1, H, 0, 5, and I, 1, 3, we need to prove that angle DEF is congruent to GHI. So the first thing I'm going to do is I'm going to go ahead and plot those points. So I'll come back here in a second after I plotted those. Go ahead and plot those as well. Alright, so I went ahead and I've plotted those points on the graph, and you see I've got these two lovely triangles here that we built. And remember, we're trying to prove that angle DEF, that's this angle right here, is congruent to GHI, this angle right up here. Okay, when we're given two triangles in the coordinate plane, the easiest way to figure out if they are corresponding or not, if they are congruent triangles, is to find their distances, the distance of each side, using the distance formula. So what I'm going to do is I'm going to go ahead and I'm going to find the distance of DE and GH, and then I'm going to have you guys finish that up on your own. So let's go ahead and do that. I'll move the paper down and we'll get going on finding the distance of all of these. Alright, so remember that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so that's what we're going to do is we're going to plug in those points in for DE and GH and then solve. Okay, so DE, we're going to say that D is our x2, y2, and E is our x1, y1. So we have x2, -5, minus x1, which is -3. All that squared, plus y2, which is -5, minus a -1 squared. Okay, now all we're doing is we're just solving this, right? -5 minus a -3. Remember, subtracting a negative means we're adding it, which means we're looking at a -2 squared, plus -5 minus a negative is going to be -4 squared. -2 squared is just 4. And -4 squared is 16, and so we end up getting to the square root of 20, which just equals let's move that down, get our friend out, say the square root of 20, enter, is 4.47. We'll go ahead and round to the nearest hundredth. Okay, 4.47. All right, now we got to find the same thing for GH here. GH, we have G will be our x2, y2, H will be our x1, y1. So x2 is -2 minus 0 squared, plus y2, which is 1 minus 5 squared, and we know that -2 minus 0 is just -2. 1 minus 5 is -4. And we see we're on the same track here, right? We've got the same numbers here as we go through the whole way, and we're going to get the square root of 20, which we just found was 4.47, which means that DE is equal to GH. Okay, what I want you to do is I want you to finish that out. Prove that the two triangles are congruent, and then using Cpctc we could say if those two triangles are congruent, the angle DEF is congruent to angle GHI. All right, good luck.